I will return this one to you after I record. Okay, so we have a gestation period for hippos, right? Length of pregnancy. We have our 200 mean and 3.5 standard deviation, right? What proportion or percentage of hippo pregnancies last more than 204 days? Because it's saying percentage, okay, it's normal CDF. And more than 204, right? So we're kind of thinking 204 is our lowest, right? Lower boundary. And then we just enter our mean and our standard deviation. And we multiply that by 100 to get our answer. And for some reason, I don't have that on my key. I got everything else except for that one. So maybe I got distracted. So that is 12.65% of pregnancies. Okay. So that's the number I'm after, 12.65. You would have to tell me what the normal CDF entries are. And this was just to double check, right? This is your 200. This is 203.5, if you want to look at it that way. So you're looking at everything, right? Percentage that would be 204, which is right about there. That's our 204 line or more, right? So it kind of makes sense that it's 12.65% based on that. Only 10% of hippo pregnancies last less than this number of days. So we're not asked to find a percentage. You know you're going to have to use inverse norm. And I was thinking about how can I help you determine the following, right? So obviously, if you think of less and greater than, right? This would be longer and shorter pregnancy, right? Like think about it that way. The higher you up the x-axis or down the x-axis, the longer it will take, right? So 10% pregnancies last less than this many days. So you're wondering, you want to have like a number somewhere in here, right? And this number, this value is going to represent like the line where 10% are below, right? So this is 10% in there. Okay, and that's exactly what we want. So you make sure you got to turn that into a decimal, followed by mean and standard deviation. And when you type that in, you get 193.59 days. If you, on top of that, rounded it to 194 or 193, that is fine. But we, in general, like to just like, especially days, it's okay to give it as a decimal. If it's number of people, it'd be different. Yeah. Yeah, sorry. Is this number off then? Yeah. Oh. Ay. Sorry. I had so much fun making the worksheet that I forgot to actually pay attention to the. I even put pictures in there for you guys. 195.51, does that sound right? Okay, I'm just checking if you're paying attention. That's all I'm doing. Avril, is that what you were gonna mention as well? Okay, we're good? That means I have to check basically everything else I did. Okay. Only 20% of hippo pregnancies last longer than this many days. So this would, imagine if you found this value, you would have 50 longer, 50 shorter. You want a value here that would kind of put 20% of the pregnancies taking longer, which means that everything to the left of that value is 80%. So I give you 1 mark for having that 80% somewhere in there. Okay, so we would use inverse norm. 0.8 needs to be a decimal. 203.5, and I have to redo that because I was not paying attention. 0.8, 200, 3.5. That's 202.95 days, or 203, 202. If you did that, I would say whenever you're not sure, give me the decimal answer and then go ahead and say approximately, right? Then round up or down if you'd like. But don't just go straight to that rounded answer, okay? Next, this is a tough one, so I'm going to put a star there. I would encourage you to fill this in regardless, even if you didn't do it, right? You just fill in it. The middle 70% of hippo pregnancies last between this and this many days. So what they're asking is saying, okay, if we take the middle, and this is 70%, right? So what are these values going to be? Like, what is this value? And like, we want basically blank and blank, right? Days and days. And so you can't do them in one shot. You have to do it separately. If this is 70%, pay close attention to this part. If this is 70%, that means that 30% are still up for grabs, right? So that means that this section here is 15 and this section is 15 because they're telling us that the middle 70 is in the middle, obviously, and so it means that we will have 15 and 15 on either side. I hope that makes sense. So I'm gonna call this I and this is double I. I'm gonna do them separately, right? To figure out I will go inverse norm. What will I feed it? If I want this value right here, I will feed it 15%, right? And my mean and standard deviation is there. I will figure out how many days that is. This is the tougher cookie here. Well, maybe not so much. Maybe I'm making a bigger deal. Maybe you're like, I got it, Mr. Dirks, I'm all good. What would I put in here? If I want this value, 0.85. Francis, were you going to say that? Yeah, so 70 plus another 15. Yes. So I need to put 0.85 in here, 200, 3.5. Okay, and I will figure out the number of days. So let me just go ahead and do that quick. Entry 0.85, 200. So it doesn't matter which one you do first. So that'd be 203.63 days. And the first one, I'm just gonna go and make that change there. That's 196.37 days. See, the fact that they gave you the standard deviation as 3.5 days, right? That kind of indicates that we're not too concerned with decimals here. Okay. So obviously you're not going to lose marks if you didn't do this. If you did do this, if you got them exactly what I got here, you get 2 bonus marks. Okay. If you were able to figure out, I wanna give you those marks there because it did take a little bit of thinking here. What's happening, right? I will just do this at the top here. This all the way to here, right? That's 85%. Like that's how I came up with the 0.85 here, right? Knowing that everything to the left of the second value amounts to 85%. So, yeah. Curious to see how many of you got it. Don't give yourselves bonus marks if you didn't do it, all right? So just stay off. Just write it all down, have it down, so that if I throw something like this at you again, you're equipped to handle that. Okay, so this page is worth 4 marks, really. Right? You can score 6 out of 4, of course. But if you didn't do the bonus, it's out of 4. Backside. I didn't know that there was a strawberry poison dart frog until I made this worksheet. But hey, there's a strawberry poison dart frog. My kids would love to have a poison dart frog, and I'm like, we're not gonna get. I don't even know. Can you have poison dart frogs? Yeah, you can have.
They're not poisonous. It's a certain
See, if you need more information, go see. What's your website? I'm just kidding. Anyways, calculate the z-score for a 21 millimeter frog. Explain what it means. So here we go. Z-score is, yeah, that's what it is, right? That's how you figure it out. You can't use inverse norm. Remember when I showed you using inverse norm? You can't. You don't have percentage, right? You don't know. So you need to use this one. So it's 21 minus 20 divided by 0.7. And that, I'm pretty sure I got that right. It's 1.43 positive, right? There are no units. That's all it is, right? What does that explain? What it means? So this will be, a question like this will be worth 2. You get 1 mark for that. It means that it tells us that a length of 21 millimeters is 1.43 standard deviations above or below. It's positive, so it's above, right? Above the mean. That's what it's telling us. So you just need to know, like, what in the world is the z-score telling us? When you just look at it, it's like, oh, it's positive, it's going to be above the mean. Exactly how many standard deviations above the mean? It's whatever the number is. Okay. It tells us that, you could also just say it tells us that the height we're just considering is 1.43 standard deviations above the mean. That's fine. Okay, so 2 marks if you have both of those components there. Different poison dart frog is 20.47 millimeters long. What percentage of frogs would we expect to be shorter? So because of the percentage question, right? Normal CDF shorter, so it's negative 10,000. 20.47, and we are at 20 and 0.7 times 100. We get 74.90 or 0.9% of frogs. So as long as you show me normal CDF entries and you have the correct answer rounded to 2 decimals, you're fine. That's a 1 mark question there, just one. See what percentage of frogs are shorter than this or longer than that. There are 2 methods of doing it. Whichever one you chose, you get the same answer. So normal CDF, I will figure out, I like things to go faster, okay? So I'm going to use this method, right? I'm going to figure out approximately, let me just give you a visual here. If this is 20, right? This is 20.7, 21.4, this would be 19.3. No, hold on. Yeah, 19.3, and this would be 18.6, and so forth. So 20.1 is right about there, just over 20, right? So this is my 20 line, 20.1, and the 22.2 would be somewhere over here. So what I'm going to do is I'm going to figure out what percentage is between here, subtract that from 100, and then it will give me the ones that I'm actually interested in, which is anything below this and above that, okay? So if I go with this method, I get 0.4424, and then I will just go 1 minus 0.4424, right? 100% minus 0.4424. So that's 0.5576 or 55.76%. So whichever method you used, if you used Normalcdf twice, sliver, sliver, just make sure you add up like you use up to 4 decimals when you do the adding, especially when you do the adding. If you didn't do that today, you actually got into a bit of trouble. Anybody got that weird e to the -4? If you did that in steps, maybe I will clarify what that means. So let's say you have 8.3 and it keeps going and you have e to the -4 like that. It's actually saying times 10 to the -4. That's what it's saying. So you need to shift your decimal over 4 places. 1, 2, 3, 4, right? You put the decimal right there and you fill the rest in with zeros like that. That's what you do when you have, if it's -6, right? Then you move it 6 places and fill in zeros for the valleys, right? The little valleys that you created. So what maybe gave you a little bit of an issue. I didn't think of that. But, if one would consider a population of 5,500 frogs, how many would be shorter than 20.1 or longer than that? So I'm basically using the answer above here. So that's just this times 0.5576, which gives you 3066.8. So you could have said approximately 3066 or 3067, whichever you rounded it to. That's when I would like you to round, when it's one of those questions. Oh, and you're probably wondering what's happening with C. I would make this a 2-mark question, because regardless of how you did it, you have to do more than just one step to get the 55.76. If you got 44.24 and you left it at that, I would give you 1 out of 2 for sure. Okay. And now the last one, which pay close attention to this. I will do more of this later in our booklet. Okay. I didn't think I thought I would be at this point by now, but it is what it is. Watch carefully. The length of bumblebee poison dart frogs, didn't know that existed either, but they do. Has a length of 33.5 millimeters and a z-score of -1. Remember, every score has a z-score associated with it. So that tells me that score is right here. That's right there, 33.5. Put a -1 underneath it, because this is my average. This is the 0 mark, right? And then another bumblebee frog has this, right? So the z-score of 2 tells me that's 1, 2, it's right here. And that's 38 millimeters, and it has a z-score of 2. So this would have a z-score of 1 here, 0, -1. Okay. Ready for this? Calculate the mean and the standard deviation of the length of the bumblebee frogs. Watch this. How many standard deviations are they apart? If you just count the gaps, count with me. 1, 2, 3. So you're saying 3 standard deviations is going to be equal to, you just go 38 minus 33.5. Okay? Because you're saying, hey, I jumped 3 times. So it's 3 standard deviations worth of jumps. And that distance between this is that. Okay? And so you go 3 standard deviations. If you go 38 minus 33.5, you get 4.5. And now all you need to do is divide both sides by 3. Standard deviation is 1.5. I will give you a way to do this down, like later on. You will know exactly how to do it. And then how do I find my average? Well, now that, by the way, this is millimeters, sorry. This is in millimeters. Oh, a student? Oh. Yeah, all right. So standard deviation is 1.5. So that means that, right, just think about it. If you jump from here to there, right, that'd be plus 1.5 to get to your average. So the mean is 33.5 plus 1.5. That's 35 millimeters. You could have gone from here and just subtracted 2 standard deviations, right? Just subtract 1.5 2 times. Yeah. So how did you get, like, you just came up with 1.5 just by looking at it? And it worked out? Normally I wouldn't. I will make this a 1 mark bonus question. So if you guessed it, you'll get half. How's that? All right? Yeah. The mean, right?
No, I got it's opposite actually. I got the standard right, but then I used L1 and L2 and
That's interesting. So you got the right standard deviation, but the mean is off. Okay, I'll have to look at it. So you get 1 bonus mark for that. So let's see here. This page is 1, 2, 3, 4, 5, 6. So we're out of 6. Potentially you scoring 7 with that bonus. But yeah, if you just guessed, I'll give you half a mark. See? You might have done it this way. This is another way for C. Normal CDF, I find everything less than 20.1 and anything greater than 22.2, I add them up and I still get 55.76. Yeah, it's one for the 44.24 and another one for figuring out the 55. Okay, so add it up. What is it? Are we 6 and 6 here or what? 6 and 4, so 10. It's out of 10. Make sure your name and last name is on there. And then let's grab